This is a tutorial on the substitution method for solving systems of linear equations. In this class, you're responsible for three methods: graphing, substitution, and elimination. The fourth method, the matrix method, is an option for independent research for your end-of-the-year project. You've already learned graphing in a previous tutorial. Substitution and elimination are the two algebraic methods, and again, you'll learn substitution here. Before we begin, I want to review the graphing method. When you're solving a system of linear equations, you can graph the lines represented by each equation and look at the intersection for the solution. When the two lines cross, the intersection is 1 point, and the solution is the coordinates for that point. If the two lines are the same line, then the intersection is all of the points on that line, and then there are infinite solutions. And if the two lines are parallel lines, then they don't intersect at all, and therefore there is no solution. So how do we do substitution? This is an easy to remember three-step process. It starts with S, U, B for substitution. Step 1, single out a variable in one equation. Step 2, use the expression in the other equation and solve. Step 3, back solve for the other variable if possible. And we're going to talk about the if possible. And because we're solving equations, we always check your answer. So here's our first example. 2x plus 3y equals 6. X minus 2y equals -4. We see that it's a system of linear equations. There are two equations and two unknowns. So we start with the first step. Do you remember it? It starts with S. Single out a variable in one equation. So we look at these two equations and pick a variable to single out. I'm going to pick this x because its coefficient is already 1. So to single it out, I need to move the minus 2y to the right-hand side. So I add 2y to both sides. And then I get x equals 2y minus 4. We just finished the first step. So what's the second step? It starts with a u. Use the expression in the other equation and solve. What's that mean? Well, we use this expression, 2y minus 4, and we substitute it in for x in the other equation. That's why this is called substitution. So when we substitute in, we get 2 times the quantity 2y minus 4 plus 3y equals 6. We see this new equation only has one variable, so we can solve for y. So the first step is to simplify by distributing the 2. 4y minus 8 plus 3y equals 6. Combine like terms. 7y equals 14. Divide both sides by 7. Y equals 2. We just finished the second step. Do you remember the third step? Starts with the B. Back solve for the other variable. How do we do that? We take our value of 2 and we substitute it back into the original equation and solve for x. 2x plus 3 times the 2 that we're going to substitute in for y equals 6. Simplify. 2x plus 6 equals 6. Combine like terms. 2x equals 0. Divide both sides by 2. X equals 0. So our solution is 0, 2. So what do we think? Could I have done this differently? Sure. I could have substituted in the y equals 2 into the second equation. And if you take a look at that, you'll see you get the same answer. X equals 0, and then the solution is 0, 2. So am I done? I hope no one said yes, because we're solving equations here, so we always check our answers. So to check the answer, I'm going to substitute 0, 2 into the first equation. 2 times 0 plus 3 times 2 equals 6. Does it work out? 3 times 2 is 6, which equals 6. It looks like it checks out. Now we could have checked out a different way because we could have substituted in 0, 2 into the second equation. Then we would have gotten 0 minus 2 times 2 equals negative 4. So negative 2 times 2 equals negative 4, which equals negative 4. That also checks out. So now we know with a lot of confidence, 100%, that our solution is 0, 2. So let's look at another example. 2x minus 4y equals negative 8. X minus 2y equals negative 4. I'm going to start with our first step. Do you remember it? It starts with an S. Single out a variable in one equation. So I'm going to pick the x again, add 2y to both sides, and then we get x equals 2y minus 4. Step 2 starts with a u. Use the expression in the other equation and solve. So I'm going to substitute 2y minus 4 into the first equation. 2 times the quantity 2y minus 4 minus 4y equals negative 8. Simplify by distributing the 2. 4y minus 8 minus 4y equals negative 8. Combine like terms. 0 equals 0. Let's move on to our next step. Back solve for the other variable if possible. This is one of the cases where it's not possible. When we get something like 0 equals 0, it means that all of the possible y's are part of the solution. And in that case, because we have something that's always true, like 0 equals 0, we get infinite solutions. So our answer is infinite solutions. Now in other problems, you may get something like 4 equals 4 or negative 2 equals negative 2. So now we know that when that happens, the answer is infinite solutions. Let's look at another example. 2x minus 4y equals 4. X minus 2y equals negative 4. So we do our first step. Do you remember it? It starts with an S. Single out a variable in one equation. If you haven't noticed already, my second equation has always been, for all of our examples, the same equation. So I'm going to skip ahead to the solution, x equals 2y minus 4. And then go to the second step. So remember the second step starts with a u. Use the expression in the other equation and solve. So I'm going to take the 2y minus 4 and put it in the first equation. 2 times the quantity 2y minus 4 minus 4y equals 4. Simplify by distributing the 2. 4y minus 8 minus 4y equals 4. And then combine like terms. 0 equals 12. What? Does 0 equal 12? 0 does not equal 12. So remember our next step. Again, this is one of those situations where it's not possible to back solve. But now we have an expression that's false. It doesn't make sense. So in that case, the solution is no solutions. And that's our answer, no solution. In other problems, when you get something that's just not true, for example, 4 equals 2 or 5 equals negative 5, the answer is no solution. So now you've seen 3 examples using substitution. Now if we compare our examples with the graphing method, we can see the solutions here. In the first example, I took the first equation and got this blue line. In the second equation, I got this red line. They cross, and so the solution is 0, 2. In the second example, remember that my second equation was the same in all 3 examples. The 2 lines were actually the same line, and that's why we got infinite solutions. And in the third example, the two lines were actually parallel lines, and that's why we got no solution. So that's it for substitution. So just to summarize, in this tutorial, we learned the substitution method. And this is the easy three-step process, SUB. And don't forget to check your answer. And remember, we looked at 3 examples here with 3 solution types: 1 point, infinite solutions, and no solution. And just some food for thought. When would you use graphing versus substitution? Are there times you would rather graph? And are there other times where you'd rather substitute? And how would you use substitution to solve this example? Notice it has 3 equations and 3 unknowns. Can you do it? Thanks for watching.